Hello everyone, this is Venkatesh. Today we are discussing about a very important topic called as Indian monsoon. So we all know Indian monsoon, it is a lifeline, be it in terms of agriculture, in terms of water resources, in terms of economy, culture, tourism, whatnot, right? So it is not a exaggeration to say that Indian monsoon is a very important lifeline for the country, right? Do you all agree it, isn't it? As a kid, I used to like the winter or the rainy season mostly because after the sudden holidays in the school time, I think as a kid, I used to, much very much addicted to the holidays in the summer, and suddenly you'll find that there is some kind of school and all. Suddenly you'll have a holiday. Why holiday is there is more rainfall. So always I had a good impression on it. Of course, with the age, you have seen the other complications, floods, droughts, the importance of water resources, everything. Okay. Anyhow, so monsoons. So it has a very, very important role to play, isn't it? You all agree with that? Okay, good. So in this session, what we'll try to do is we'll try to have an understanding of the nature of the monsoon, the characteristics of the monsoon, and how it is a very, very important climatological phenomena which has role. So we will be dealing more from the perspective of climatology. That is, what is the monsoonal, what are the monsoonal winds, how are they driven, what are the things and all. Let's start in detail. So what are monsoons actually? If you see monsoons, they're nothing but monsoon means nothing but seasonal winds. So we all know monsoon is derived from an Arabic word mausim, which means seasonal. What is that? See, the moment I say monsoons, wind systems, you will say southwest winds, which you see in the summer part. You can see here southwest winds, and then the northeast winds. So what is happening? The wind systems which are southwest are moving now east. So what is happening? There is a reversal of almost 180 degrees. So this is the chief characteristic of monsoon. What is monsoon? Means season. What do you mean by season? There is a seasonal wind. It is a seasonal wind. So that is the thing. Monsoons are seasonal winds. And they are known for what? Reversing their direction with a change of season. So 180-degree reversal of winds. You can see here. As you can see in the picture on the right-hand side of the screen, you can clearly see that there is a now southwest monsoon which is shown in the summer, where the air is entering into the India landmass from the ocean, right? Entering into India. Whereas in the left-hand side of the picture, you can see the winds are moving from land to water. So water to land, land to water. This is what a simple explanation of monsoonal winds are. They are called as the seasonal wind systems, which reverse their direction with a change of season, right? So this is the thing. So remember one thing, monsoon means season, and the characteristic thing 180-degree reversal of winds. Not just that, it has so many other characteristics. I think if you have observed the map, if you have observed the newspapers of late in the recent era, or you'll see that, say, example, every monsoon enters into India with a sudden outburst, which you call it as burst of the monsoon. Typically happens around May, June. So if you talk about the landmass of India, the major landmass of India, apart from the islands of Andaman and Nicobar, you will see that that burst happens in Kerala, right? Kerala. So the monsoon enters into India with a sudden outburst, as if like someone is somebody is what do you say? They're kicking the door and entering into the room. They're not knocking. Can I please come? No, 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 no. They're kicking the door and entering into the room. That's what the burst. But another characteristic feature, the moment they enter into the room, it is not like they are covering the entire India at a very, very quick pace. It's a gradual advance. It will not happen in day one. So when the monsoon bursts around May, June, late May, early June, the gradual advance, it might complete by sometimes around July first week. If you see the 2023 progress of the monsoon, advance of the southwest monsoon, you can all see this picture here. You see, monsoons have entered into India. You can see the blue color is the actual date and the red color is the normal onset. You can see the normal onset is 1st June. And by the time they complete the Kashmir part, you can see it is almost around 30th June, right? You can see parts of Rajasthan, which are covering in the last parts of, or the early last part, where is almost around the first week of July, isn't it? Right? So you can see this. Of course, there is a variation of this year. Southwest monsoon covered the entire country on 2nd July 2023. This year, we have covered the entire country. So this is the phase. So even here, you can clearly see that we need not go into the exact details of when and where and all. Just can have a rough understanding that it starts from late May and completes by early July. That's the rough idea. So the progress of the monsoon, we have seen that there is a gradual advance. See, we are talking about a topic called India's monsoon. We have said that India's monsoon is regarded as the lifeline of India, be it in terms of what? In terms of water resources, in terms of water resources, in terms of climate, agriculture, and all. Water, climate, agriculture, economy, all those kind of things. Now we have to understand everything. No, that is what we are trying to know. If you see, it is gradual advance. At the same time, there are also breaks in the monsoon. Breaks in the monsoon. The breaks. It's not like June, July, August, September, which is southwest monsoon. It is not like there is a what is a continuity of rainfall. There are so many amount of breaks. Sometimes you'll have 2 to 3 months of no rainfall. Sometimes you'll have heavy rainfall. So there are certain breaks. And by the time they go back, see, they have entered. Now what happened? Monsoonal winds have entered into a room by kicking the door. But as soon as they're kicking the door, that energy is lost. Now they're slowly moving. It is not like as high. The nature, the energy to which they have kicked the door, that energy is not maintained as they enter into the room, as they completely complete the movement within the room. So after it's in the room, suddenly they will be disappearing. Suddenly they'll be coming back. That's what is the breaks of the monsoon. And the moment they wanted to go out of the room, it's a gradual retreat. It is not like the way they have entered. As soon as kicking into the door, now they don't want it to go. It is almost like a kid in the park. They don't want to go to heaven, wanted to enjoy, right? They go it very, very, very slow, gradual retreat. Starts somewhere around September and ends somewhere around October. So you have a gradual retreat. And in the process, the way they have given rainfall, there are different spatial areas where there is so much amount of variation. And by time, that is the thing, breaks we are discussing here, that is the time. Spatial and temporal analysis are the variations of rainfall. You can see here, you see the map of India. The significant portion of rainfall in India, this is a map describing the rainfall map of India. Significant portions of rainfall is impacted by monsoons. So you see that monsoons will determine which areas are getting how much amount of rainfall. And recently, in the late July of 2023, Indian government has submitted a letter has submitted an analysis in the parliament talking about the analysis carried out by IMD department on the monsoon rainfall variability and the changes. So they have observed that 5 states, particularly UP, Bihar, West Bengal, Meghalaya, and Nagaland, have shown significant decreasing trends in the southwest monsoon period over the last 30 years. So what we are trying to tell is there is a spatial variation to it. So this is the background. So now what are you knowing? You have known by now that monsoons means they are the seasonal winds. They are having certain characteristics like burst of the monsoon, something like a gradual progress, breaks, and all those kind of things, right? Spatial temporal analysis and all those things. Now, we have to explain conceptually why these things are happening. Now, what are the reasons to give it? Monsoonal winds, they are not as simple as we imagine. but they are having so much amount of complexity. They are affected by various factors. You see here, this is the left-hand picture. You can see here, there is a southeast trade winds which are entering into the northern hemisphere, becoming southwest monsoons and entering here. There is a low pressure area here. There is a jet stream. There is an ITCZ which we are talking about and all. So what this picture says is, the monsoonal winds which we see called the southwest monsoons into India, they're not as simple as we see. They're affected by various factors. Okay. So we will start with understanding about various factors. Before we start about the various factors, now this is the left-hand picture talks about the southwest and the right-hand picture talks about the northeast, which is roughly the 180-degree reversal of winds which we see with respect to multiple seasons. Okay. So with this, let's go to the next one. Let's understand the factors now. The first factor you will need to understand, simply, very, very simple point, the differential heating of land and water. Broadly, before we get into the major details, understand broadly that I think we all have studied the concept of land and sea breeze. So we see that Indian landmass, this is extremely heated up in summer. You all know because of heating of the air, there will be convection, the air will rise. Now, if this is the surface, now air will rise. Now, as the air rises, what happens? There will be a low pressure area. When compared with the nature of the land heating, ocean will be definitely will not be heating to that extent. So ocean is known for slow heating and slow cooling. So if it is slow heating relatively when compared with the land. So when compared with this, this is a high pressure. So winds move from high pressure to low pressure. That's the thing. Similarly, in winter, we all know land is rapidly cooling, rapid cooling, and water slow cooling. I think you have discussed this concept n number of times. Specific heat of land and water are very different, isn't it? Right? So with this high pressure, now what happens? Land, it is slow heating and slow cooling here, right? Slow cooling. So in winter, it cools down very, very slow, but the land cools down, but the water cools down. Sorry, the land here cools down very, very fast. Land is known for rapid cooling. So now movement rapid cooling, what happens? It becomes a high pressure area because everything comes together and the particles fall down. Remember the inversion of temperature concept? Relatively, when compared with this high pressure, Indian Ocean is a low pressure area. Why? Slow cooling. When compared with this high, this is low. So winds move from high pressure to low pressure. This is what the differential heating of cooling and land water. And understand, this is the fundamental. But the problem is, you have to always explain everything. No. Why there is a burst, why there are breaks, why there is a continuity for 4 months. It is not like few days. It is almost for 3-4 months. You have southwest monsoons entering into India. Right. So the base is always, remember this. Indian landmass always has to be low pressure. Relatively, Indian Ocean has to be high pressure. Any factor which favors low pressure on the Indian landmass and which favors high pressure in the Indian Ocean is a favorable factor to monsoons. Why? There will be more winds which blow towards India. That is what the conceptually you have to remember. Okay. So the base is this, but this concept or could not explain everything. It could not explain the burst. It could not explain the breaks. Now let us go to the next concept. There is something called as ITCZ. Second factor, intertropical convergence zone. Now, what is intertropical convergence zone? ITCZ means it is a zone of low pressure area which you find which moves across the world which moves across the different parts of the tropical part by the apparent movement of the sun. You will see that ITCZ is in July, in the month of July, it is almost virtually much in the northern hemisphere, almost to reaching towards 25 degrees, 30 degrees northern latitudes. Now, ITCZ is nothing but it is a zone of convergence of trade winds, that is northeast and southeast trade winds meeting point. Right? Remember the concept of equatorial low pressure zone? So that is what intertropical convergence zone is. But we all know that the vertical rays of the sun, the apparent movement with the revolution and the tilt of the axis and all these things we have discussed, on 21st June, vertical rays of the sun are on Tropic of Cancer. So because vertical rays of the sun are in the northern part of the hemisphere, what will happen? You all will understand that because of the vertical nature of the rays being there in the northern hemisphere, there is more heat, there is more rising, and that leads to development of low pressure zone, which we call it as ITCZ. Now you all know this, as you can see in this picture, ITCZ is exactly located on the north side of India, almost moving towards it. Now from June, slowly it progresses across India, and by July, it will come towards the northern part of India. Now this is the reason why, now this is a low pressure. Now anything which is a low pressure, we all know it. The base we have studied, this picture here. There is an ITCZ also exactly over India. Now this is a low pressure. Winds are attracted towards the low pressure. Why do you think these winds are moving towards this? It is because of this low pressure area. So it is the movement of the ITCZ, which is in the month of June, July, August, September. You can see here, ITCZ will be here only. So this is a low pressure. The moment there is a low pressure, there is a pressure gradient and winds will be moving towards it from Arabian Sea and Bay of Bengal. But by the time of January, where are vertical rays of the sun? By September? You can see that by September, vertical rays of the sun will be at the equator. And by December, vertical rays will be in the southern hemisphere. Because of this, what happens? Everything shifts southwards. I think you have discussed the concept of shifting of pressure belts and subsequent wind systems. Similarly, ITCZ moves up and down. The more it goes towards the northern part, especially in the months of June, July, August, September, that will favor the southwest monsoons. Similarly, January, that will favor the northeast monsoon. So this concept is not wrong. The concept of ITCZ is not wrong. It is also explaining why there is a shift in the monsoonal winds, why the southeast trade winds are modified into southwest. It is explaining it, but it could not explain the burst of the monsoon. It could not explain other factors which are there, the breaks of the monsoon, all those kind of things, isn't it? Right? So, but ITCZ is important. Largely, what have you discussed until now? The first point which you have discussed, the first factor, differential heating of land and water. Overall, I can say that in summer, land rapidly heats up, low pressure. In winter, land rapidly cools down, and hence it is a high pressure. Relatively with that, ocean will be having high pressure, land mass will ocean, and here in the winter, ocean will be having a low pressure. This factor is correct. Largely, this is true. With this, we also have understood that how the low pressure center, which is caused by heating, is also because of the movement of the low pressure of the global distribution of pressure, which you have understood through ITCZ. So even ITCZ is shifting northwards. You see here, why this north is more here and very less here exactly at this July month. You can see this is ocean. There is less heat. That is why it is nearer to the equator. If you see here land, more heat. That is the reason why it is shifting north. Imagine this entire landmass is removed. Everything is ocean. Then ITCZ will be exactly here. It will not change. Okay, it will be changing minor portions. The major portions why it is shifting is dominance of land in the northern hemisphere. Okay, this is one of the reason. Of course, you all have understood the tilt of the axis, that factor and all. But as of now, for this topic, you can see the role here. Now let us move to the next factor. Now you see, in fact, the earlier studies have observed that monsoons are a very regional system. It's a low pressure system or the Indian Ocean, and there are winds coming from the ocean. Just like how do you have land breeze and sea breeze every day, you will have summer winds and winter winds. That is what we are calling a seasonal shift, and that is what is regarded as monsoons. But with the advent of technologies, with the advent of understanding of events across the world, the monsoons are so complex and they are so unique to India because of various factors. So there are some other factors, say Tibet, say the role of jet streams, jet streams. So you have three jet streams. Subtropical westerly jet, as you can see here, the red color, you can see this black color one, subtropical westerly jet. Similarly, there will be tropical easterly jet, which we'll understand further, and Somali low-level jet stream, Somalian low-level jet stream, which are there, which have a role to play in India's monsoons. So we'll discuss about that. See, broadly, these are the containing factors. Understand, there's a car. For a car to have a smooth running process, we need to have the engine, we need to have the petrol, right? We need to have that petrol, we need to have that the gear system, which has to be at right place. You cannot run the car in neutral, no. It has to be taken to the next gear, right? You will not see, everything is there. The car is going on very well with it has a smooth engine, it has smooth capacities and all. There is no petrol. What will happen? There is good petrol, but the engine is bad. What will happen? So like that, there are variety of factors which influence. It is not only one factor. Okay, right? I hope you are getting my analogy there. Similarly, then there are other factors. Engine is good, all other factors, but sometimes ambience. Ambience is also important, right? So if I'm from Hyderabad, biryani is very famous in Hyderabad, isn't it? So the core things, what do you need for a core biryani to be very good, right? Say things like you need the good rice, the whatever the smell of the rice, right? The beautiful aroma, isn't it? The dum, which you call it as the masala, where you will put it all the things, pieces, and everything into one major bowl, and you try to heat that with rice. Now all these factors are there, but the restaurant, you also need a good ambience of the restaurant. It's not like you will eat it at the at one place. So there are other factors which are also having a very important role. Say things like El Nino. This is also an important event, El Nino. This year, 2023, there is a talk about El Nino, which will provide amount some kind of droughts to India during the month of August and September 2023. Similarly, you will observe the temperatures of the ocean, because that will determine the pressure. And we shall talk something called as Indian Ocean Dipole. Okay, these are the main factors. And finally, just after eating the entire biryani and all, there is also something like a dessert which they give at the end, no? Right? So mouth freshness, even mouth freshness have a role to play. Sometimes, occasionally, you have new things called as Madden Julian oscillations and all, which might have an impact. We will discuss this later. As of now, I want you to understand what factors were there, whichever you have studied. I want you to understand this. One, land and water heating nature, role of ITCZ. These two are there. After that, importance of Tibet, importance of jet streams. Then you have El Nino, the events happen across the world because of this, and also something called as Indian Ocean Dipole, which observes the temperatures of Indian Ocean. These are the main. Okay. Now let us see the Tibet. What does Tibet do? If you see the Tibet, see Tibet, it's a huge area. Tibet, it's a huge area. You can see here, you have the mighty Himalayas, the black color, or the brown color here, mighty Himalayas. Then you have a huge area here. It's a big plateau, Tibet. You can see this. It's a huge landmass. So observe it from the phenomena of something like this. This is a flat. Now imagine you are coming from the Tibet side towards the Indian Ocean. So there is a huge flatland. You have the mighty Himalayas, then you have the plains, and then into the ocean. Now this is the sea level, mean sea level. Look at the height. The height, the height of Tibet, almost 3,000 to 5,000 meters height. Then the Himalayas, Everest, Mount 8,850 meters, Mount Everest. And this is the mean sea level, 0. Now, if you see the globe, it's one of the huge landmass and located at a higher elevation. Now, because of this, and the surrounding regions of Tibet is also, there are so many mountains. You can see here the Himalayas, you can see the Kunlun, Tian Shan mountains and all those things. So there is a huge amount of flat land here, which is the elevated portion. A flat land is an elevated portion. That is what is called as a plateau, right? Plateau is nothing but what? A flat land, but at an elevated portion. So you have a huge area which acts as a, it gathers more insolation. So simple point. What is that role of Tibet? So there is a scientist or a climatologist who studied it by name Koteshwaran. He observed that Tibet location, in terms of the mountains surrounded by it. So it's a flat land surrounded by mountains, but with more elevation. So naturally, it acts like a heat engine. Which gathers more amount of insulation, and it will develop something as a low pressure area. So what happens? There is a Tibet, it gathers more heat, the air particles rise, keep on rising, low pressure. So what is happening towards India is, this is a very important role to play that in Indian landmass, it's get heated up in the summer, low pressure. ITCZ will also act as a low pressure. And when you take at a regional scale, the Tibet is also a low pressure. What is happening? There is a very good pressure difference between the landmass and the ocean. So southwest monsoons are continuously able to move. So that is the importance of Tibet. So what does Tibet do? It will act as a low pressure and it will try to make the pressure gradient difference between land and the ocean on a global scale, on at least on an Asian scale, at a decent thing. That is one more thing, right? Now, all these things lead to another thing. We also need to understand something called the jet streams. As of now, understand only this. Tibet, what does it do? It gathers more heat from the surroundings. That will lead to development of low pressure. So if you see on a regional scale of South Asian landmass, it is acting as an important pressure gradient difference between India and ocean. So anything which is low pressure, it is good for the winds to enter, no? That is the role of Tibet. Then came something called as jet streams. Now we all know jet streams. First of all, jet streams means it is neither a jet nor a stream. We all know it. These are fast moving wind systems. Observed in the upper atmosphere. Fast moving wind systems in the upper atmosphere, which are very, very meandering in nature. So you can see here, they blow like this in the upper atmosphere. This is the ground level. In the upper atmosphere, they meander a lot. So these are the jet streams. One such jet stream, which is a very permanent jet stream, which is observed exert the world, is subtropical westerly jet stream. As you can see, subtropical. It is exactly located in the subtropical latitudes around 20 to 30 degrees north and south. 20 to 30 degrees north and south latitudes. And usually jet streams move from west to east. That's why it is called westerly jet stream. And you see around these latitudes. And you see, this is the exact place where Himalayas are located. Now what happens is, these jet streams are known for creating high pressure conditions whenever they oscillate onto the ground level. So if you see this, these are fast moving winds. When they enter into India, they dump all their cold air into India, and that will lead to high pressure. Now, if you observe, when do you find, now I'll ask you a question. When do you find heat of the monsoon? When do you find the landmass of India heated up? It is from the month of April, May, isn't it? Am I right? In April, May, there is summer, there is more heat. But why do there is a low pressure area which supposed to be developed by April, May is not causing the winds to develop? See, the low pressure area on the Indian Ocean because of insulation has been formed in April, May itself. Why they are waiting until June as if there is a muhurtam to it? There is a muhurat, isn't it? Okay, we will enter only on June 1st. Why not April? It is because whatever the difference which is caused by the heat, jet streams are also causing a high pressure. So it is like, see, this is the wind. One wind is being attracting towards this. One force is attracting towards this. Say this force is something like, you see, the heat difference. So this is the wind. There is, see, something like one is attracting, one is pushing and one is pulling. Imagine this is the heat difference. Imagine this is the Tibetan plateau. Imagine this is the ITCZ. So this is dragging the winds on one side. This is, you all played this tug of war, no? We used to play as a kid. We have a thread and we used to pull it. So there is one side which is pulling and there is the other side, jet stream, which is causing a high pressure. So this is the low pressure, this is low pressure, but this is causing high pressure. But the fact of matter is, jet stream's force is much higher because of its fastness. The impact of the jet stream is much higher. So that is the reason why, despite the landmass of India being heated up in the month of April, May, there is no monsoon. You have monsoon only in the month of June, July, because it will be the subtropical jet stream which will determine when do you have a burst of the monsoon. So what happens is, as long as the subtropical westerly jet stream stays in India, you'll find that it will be neutralizing the high pressure. What is that? Subtropical westerly jet stream neutralizes the low pressure found on the land. This low pressure is because of heat. This is being neutralized. But what happens is, as everything shifts northwards, by June, subtropical west, look at the location of jet stream here. This is here now. Look at the location now. As everything shifts northwards, the shifting of pressure belts, subtropical westerly jet stream also shifts northwards. As it shifts northwards, now there is no one to stop this force, no? So the original low pressure is restored. Exactly at the same time, this jet stream, as it is lost, you will find that there is another jet stream. Now you all know from the Tibet what is happening. The air is rising. You all have understood. You all have understood this picture, no? So if this is Tibet, the air is rising from the Tibet into the upper atmosphere. Now what happened? Suddenly this jet stream which is there, this disappeared. So there has been a vacuum now. So what happens is, whatever the heat which is rising from the Tibet moves in the upper atmosphere, and there develops another local level jet stream called easterly jet stream, and this will descend into the Indian Ocean, say at a place called Mascarene Islands. So what is happening is, see the points. First, subtropical westerly jet stream. What are they doing? Initially, they neutralizes the low pressure. They neutralize the low pressure conditions of the land. So this is the month of April and May. So the land has low pressure conditions. Land low pressure because of summer heat. But this land low pressure is neutralized because jet stream means always whenever they come to nearest to the land, they can create high pressure conditions, right? This is what. Number two, continuation. Shifting of the pressure, shifting of the jet stream with respect to northward migration of the sun. You all have seen it. The sun migrates towards, that is what you call northward migration of the sun. That is, the vertical rays of the sun are not at a static line. The vertical rays of the sun are at equinoxes and solstices, remember, June 21st, vertical rays of the sun in the Tropic of Cancer. So because of that, everything shifts northwards. So shifting of the jet stream with respect to northward migration of the sun. So what happens? Subtropical westerly jet stream, it has a southern branch disappears south of Himalayas. You have Himalayas, south of Himalayas, it disappears. The moment this disappears, what happens is, on the land, low pressure conditions are restored. Low pressure conditions are restored. The moment land low pressure conditions are restored, what will happen? Understand? There is a low pressure. Now there is a wind which wanted to enter into India. See, from April and May, you are closed it. No, now they wanted to enter. Imagine say, you have an AC. You cool down your room to 16 degrees, chilled wind, chilled air. Suddenly you remove the door. Look at the difference between the heating of the outside and the inside of the room. How the winds blow. That is what the monsoon burst of the monsoon is. The moment this is happening, the tropical easterly jet stream develops. The next point, tropical easterly jet streams develops between Tibet plateau and the ocean Mascarene Islands. Now, what is happening? What is the role of this Tibetan jet stream is, the more the Tibet gets heated up, the more the air rises, the more the air moves in the upper atmosphere as part of easterly jet stream, and this jet stream dumps into the ocean. I told you just now, whenever jet stream dumps its air into the ocean, into the ground surface, it will create high pressure conditions. So this tropical easterly jet stream creates high pressure conditions, and these winds starts moving into India. So understand, no? Why do you think that winds are continuously moving from, say, June, July, August, September? Now understand this picture. You see, this is Tibet, this is the Himalayas, then you have the plains, and then the means. Now this is the, say, ocean. Now this is where the ocean begins. Now land here, ocean here. Now this is Tibet. Now what is happening? Normally there is a low pressure area here. There is a low pressure area here because of heat. Okay, but what happened? There is a jet stream, subtropical westerly jet stream. Now when it flows here, it will be creating high pressure conditions. Jet stream, right? Now this jet stream is lost in June, July. Now this low pressure, there is another jet stream, tropical easterly jet stream. Let me show you with another color. Tropically, whatever the air which rises from here moves in the upper atmosphere, dumps into the ocean, and it creates high pressure. Now this is high pressure and this is low pressure. What happens? Winds enter into India like anything. Enter into India. So the analogy is burst of the monsoon. What is the reason? Burst. Subtropical westerly jet stream, northward migration, plus tropical easterly jet stream development. What is they're doing? They're developing the contrast between the low pressure and the high pressure. Because of this, there is a burst. Now, occasionally, in the months of June, July, August, September, the breaks are there, monsoon. Whenever subtropical westerly jet stream comes into India's landmass, you can see here, subtropical westerly jet stream comes into India's landmass, as you can see this picture. Sometimes they are absent, sometimes they are not so. So whenever they are absent, you are finding a good monsoon. Whenever they are present, there are breaks in the monsoon. So the jet streams have explained the burst and also the breaks. Hope you all have understood this point until now. This is about the first session of the monsoons. In the next session of the monsoon, we'll discuss about the remaining things like other jet streams like Somalian low-level jet stream, the role of El Nino, Indian Ocean dipole, and very other minor things like the presence of aerosols or else something like a very local phenomena which occurs occasionally, something called as Madden-Julian oscillation. Hope you all have understood the process of monsoon now, mechanism of monsoon, right? So this is about the mechanism of monsoon. This is Venkatesh signing off. Thank you very much.